Okay, in this video we want to compare the disk method and the shell method for finding the volume of a solid revolution formed by revolving a certain region about either the, well, could be a vertical line, could be a horizontal line, could be the x-axis, y-axis, and so forth. So in this particular case, we have the function y equals square root of x, the horizontal line y equal 1, and the vertical line x equals 0, which is the y-axis. That region will be revolved about the x-axis. Now we did this region using the disk, so we do the same thing, same problem using the shell method. I'll put a link to that particular video in the description. But here's what we have. Here's what we got using the disk method. Now anytime we take a representative rectangle and place it perpendicular to the axis of revolution, in this case it's the x-axis, we're using the disk method. So if I draw my perpendicular rectangle here, and remember this is real tiny, so the integral is a limiting process and it sums all of these and calculates the volume based on the formula for a circular cylinder. Now the width of this rectangle, so here I'm using the disk method. I have the rectangle perpendicular to the axis of revolution. The width of this is delta x, which will turn out to be dx. That'll give me the variable of integration, which of course is x. And then we have a radius going from the axis of revolution all the way up here. That's 1. From the x-axis to this point, because remember this is the equation of y equal 1. So that's how I get this one here. So basically this thing is going to rotate. We're going to rotate this region right here, about the x-axis, and there's going to be a hole here. So we subtract this. That's why this subtraction is here. So the outer radius is 1, and we square that because the volume of a cylinder is pi r squared times the height. So this is 1. And then we subtract the inner radius. This is r here. And that's the distance from the axis to this particular point. And since this has, the curve has equation, the square root of x, that's the inner radius. We square it. And I did this in the last video. Just a matter of this then will give me 1 minus x, and then I integrate and apply the limits from 0 to 1, and I get this answer of pi over 2 as the volume. Now if the region, this region was going to be round about the, say, the y-axis, and I'm using the disk method, then my rectangular strip would have to be perpendicular to that. So in this case the width is dy. So in this case the variable of integration would be dy. What we're going to do now is look at the same problem using the shell method. Now if the rectangular strip that you use is laid out parallel to the axis, then it's the shell method. So this would come out this way. This would be your strip. And notice the way this is set up, the width of the rectangle is along the y-axis, so the variable of integration in this particular case is going to be the y variable. My volume then is going to equal to, and for a shell, instead of pi, it's 2 pi here. We start off with, and it's the integral from going along the y-axis. Again, it's from this point to this point. You see the point here is 1, 1, 1, where the line y equal 1 and the function y equals the square root of x are, they intersect at 1, 1. So my interval, limits of integration are going to go from 0 to 1. And then as you saw in the last one, I had to find the radius, and that the radius would be the distance from the axis of revolution, which in this case is the x-axis, to the rectangular strip. That's just going to be y. That's just going to be y. So this will be y here. The thickness of course is going to be dy. And then we need the length of this. So it's going to be this distance subtract this distance. So it's from here to here. Well, that's x. That's just x. This distance from the y-axis to the curve is x. But since we're integrating in terms of the variable y, we need this in terms. So let's solve for x. So this will be square both sides here. That'll give me x, and then y squared. So the length of this rectangular strip then is x units, but in terms of y, that's y squared. So that's going to be times y squared. Variable of integration is y. Now we just evaluate this. So this will be 2 pi integrated from 0 to 1. Multiply this out, we get y to the third dy. And then we just integrate here. 2 pi times y to the third, basic integration there, integration. Add 1 to the power using the general power rule for integrals. 3 and 1 is 4. Divide by 4. And the limits of integration are from 0 to 1. So this will equal 2. Evaluate this thing at 1. So put a 1 where the y is. 1 to the fourth is 1 over 4. That's 1/4 times 2 pi. That's 2 pi over 2. And then minus the value at 0. When you put 0 where the y is, this will be 0. 0 times 2 pi is still going to be 0. So the answer is the same as we got with this method. Pi over 2 cubic units. Now one method might be better than the other depending on the type of integral that you get. So if you're given a choice, of course sometimes the instructor will just tell you use this method or use the shell method, then there you don't have any choice. But if you have a choice, you take the one with the easier integral to evaluate. So again, I just want to point out again that when you put your rectangular strip perpendicular to the axis of revolution, you're using the disk method. When you put the strip parallel to the axis of revolution, you're using the shell method. Thanks for watching. We'll see you next time.